Hi, all my YouTube viewers. It is Crystal here. I'm just here this evening because I wanted to make another video. I'm working on SQL at the moment, which is also called SQL, and I'm using it on Kaggle because Kaggle has the ability to program in SQL if you use it as a comment in Python. So I imagine it's a little bit different from most of the SQL that people work on, but that's how Kaggle gets around it. And then Kaggle has to have a library which helps you work with SQL. I did actually find, I think it's on W3 Schools, you can actually practice a little bit of SQL on W3 Schools, but I didn't have much success at it, which is why I'm sticking with Kaggle. So what I'm using is the incidents around Austin, Texas data set, which is a text file, but you can use it with BigQuery. So that's what we're doing. We're using it with Kaggle as well. So the first thing that we're going to do is we're going to declare our problem statement, which is we're going to analyze incidents around Austin, Texas. And then what we're going to do is we're going to import the libraries. So from google.cloud, import BigQuery, and BigQuery is what you use to work on these BigQuery data sets. We're going to import BQ Helper, and that's a Kaggle library to help you actually work with BQ datasets. From BQ Helper, import BigQuery Helper, and that's another helper to enable you to work on SQL within a Jupyter notebook. We're also going to import NumPy as NP to create NumPy arrays and make numeric computations. And we're going to import pandas as PD to create data frames and process data. We're going to import matplotlib.pyplot as PLT to visualize data, and Seaborn as SNS to visualize data as well. So we're going to format for BigQuery. So Austin data equals BQ underscore helper dot BigQuery. Active project equals BigQuery public data, and dataset name is Austin incidents. So now you're going to client equals BigQuery dot client. BQ assistant equals BigQuery helper, and BigQuery public data and Austin incidents. BQ assistant dot list tables. So there's 5 tables, and I'm going to be using the table from 2016. We're going to convert the table to a data frame. So BQ assistant dot head incidents 2016, and so you're going to see the first 5 rows of the data frame. So you're going to have unique key, description, date, time, address, longitude, latitude, location, and timestamp. We're going to print the schema, BQ assistant dot table underscore schema incidents 2016. So this is similar to info in Panda. So it tells you the type of column a feature is, and it tells you the mode, and the mode is nullable, and it gives you a description. So now we're going to ask the question, we're going to do a query on what type of incidents. So incidents equals comments, select, descript, date, time, address from BigQuery public data dot Austin incidents dot instance 2016. And I said where descript is null because I didn't want to print anything out if there wasn't anything in the description. And then so what we also want to do is we want to see how much data it's going to cost us to run one query, because Kaggle will only allow me 5 terabytes of data a month, and then if I exceed that limitation, then I have to wait until, I suppose, the next month to get more data. And so far, I haven't exceeded my 5 terabytes, but I'm trying to select data sets that are not that big, and I'm trying to not do that much, which was good because last weekend I spent the entire weekend reading a book. And because I spent the entire weekend reading a book, that meant that I couldn't work on SQL. And I also did a book review on that book, and it's in Medium Publications if anybody's interested. It was called One Day I Will Die by Sunny Kohei. So if anybody likes to read fiction, let me know, and I'll give you the information for that book. Okay, so drive run config equals BigQuery dot query job config. Drive run equals true. Drive run query job equals client dot query incidents comma job config equals drive run config. And then you print how many bytes it's going to take to run one query. And I think it takes about 5 megabytes to run one query. And as I said, because I try to select data sets that are not very big, so I don't use all of my data up very quickly. So query 1 equals client.query incidents.result.to data frame query 1. Let's see what we've got. And so we've got a data frame that gives you the description, the date, time, and address. So query 1.in unique. And so what I wanted to do was I wanted to see how many unique incidences, unique values for each feature. So description has 409 unique values, date has 475, time has 1440, and address has 2812. Type incident equals query 1.descript.value counts type incident. So this gives you a listing of all of the references, all of the incidents of each description. So crash leaving the scene is 7778. So that was the highest reported incident. Theft was 6418, so that was the second highest reported incident. Family disturbance was 6036, so that was the third highest incident. So you just want to check how many times you had a particular description for an incident. So what we're going to do now is we're going to check the top 15. Top 15 inc equals type incident 0:15. Top 15 inc equals PD data frame. Top 15 inc reset index. Top 15 inc. So you see that these are the top 15 incidents that are recorded, and it gives you an account of every incident that has that description. And so the 14 is auto theft. And they also had harassment as number 12. Because you have to keep in mind that in Python, your numbering starts at 0. So now what we're going to do is we're going to use Matplotlib to make a bar chart of the top 15 instances. And then when we use Matplotlib to make a bar chart of the top 15 incidents, you can see that crash leaving the scene is the highest recorded incident, and theft was the second one. And then it goes all the way down to 15. So that will give you a count of every incident. So now we're going to select the dates of the incidents. So dates is another query. Select descript, comma, date, comma, address, comma, extract hour from time as hour, comma, extract week from date as week, comma, extract day of week from date as day of week. And then it's from the BigQuery Austin incident, BigQuery public data Austin incidents incident 2016, and where date is not null. So here we go. Query 2 equals client dot query dates dot result dot to data frame. So you're going to convert it to a data frame. So you've got your description, your date, your address, your hour, your week, and your day of your week. And then so we check the day of the week and we do value counts on that. And you can see that the highest day of the week that incidents are recorded is day number 6. And I'm assuming that's on Saturday. And the lowest day of the week where incidents are reported is number 1, which I'm assuming is Monday. So now what we're going to do is we're going to use Seaborn to create a histogram of the days of the week. And you can see that it said day number 6, which I believe is Saturday, is the highest reported incidence, and day number 3, which I believe is Wednesday, is the second highest reported incidence. And you can see day number 1, which I believe is Monday, was the least reported incident. So now what we do is we check query 2, we check the hour value counts. So this is the hour of the day. And so you can see hour number 12 is the highest value count, and hour number 5 is the least value count, and that's the least incident of the hour. So it records the hour that the incident was reported. So what we're going to do is we're going to use Seaborn to make a histogram of the hours. So again, you can see that hour 5 is the least reported incident. So I'm assuming people are sleeping at 5 o'clock in the morning. But hour 12 is the highest reported incident. So most people are going to be awake by 12 and are going to want to report an incident. So now what I wanted to do is we're going to do a query of the day of the week to report the incidents. So select count unique key as num incidents, comma, extract day of week from date as day of week, and then from BigQuery public data Austin incidents 2016, group by day of week, order by num incidents, descending. So query number 3 equals client.query devweek.result.to data frame query 3. So you can see that the day of the week number 6, which I believe is Saturday, is the highest reported incidence, and day number 1, which I believe is Monday, is the least reported incidence. And what I also had previously done was I had selected the week of the year. I believe it was the week of the year, but I don't know what happened. But up to about week 40, you had a lot of incidents. And then after week 40, you didn't have a lot of incidents. And I wasn't sure what happened. I don't know if they just input the data incorrectly or if they changed their reporting procedures. And when they changed their reporting procedures, that meant that less incidents would be reported. So I didn't feel very good about that. So I decided not to include that in the query because it just looked a bit odd to me. So obviously, if a person was going to be using this, that's something that they would have to research. They would have to actually find out why that happened, why you had up to the first 40 weeks, you had lots of incidents reported, and then after that, you didn't have a lot. But since it didn't look very good to me, I'm not sure exactly why that happened. I didn't include it. Now, what I could do is I could do, come back here. Mm, and I could, like check 2011 and see what happened in 2011. So to see what the values in 2011 are and how they compared to 2016. So that's something that I could do. I probably should just make this SQL Austin instances 2016 because that's what I used. And the next time I'll put the year in it. So that's it for this code review. I hope you got a lot out of it. I'm still learning SQL. I'm going to look for a way that I can practice SQL online for free, and we'll see if I find anything. And if I find anything, I'll definitely make some code reviews on that. But I better go ahead and conclude this video. If you like my video, please like, subscribe, and I look forward to communicating with you in the next video.